This is a remote-controlled ATR. It's controlled with a simple wired controller. But what if I didn't want to control it anymore by myself? What if I wanted to let it make its own decisions? In that case, the question is, can we automate it? Some Velcro with blue tack attached on the bottom. Professional materials. To allow our robot to look around, we'll be using a servo motor. There'll be more on how this works later. To let the robot detect objects, I'll be using this ultrasonic sensor. I'd best not throw this one. The microcontroller, this Arduino, is the tool which will take inputs and use some code to create outputs. The Arduino can't drive everything on its own, so we need this motor shield board here to help it out. Tape, to stick things to each other. This platform, made from tape, Lego and Velcro, will house the electronics on top of it. And for power, we'll use 8 1.5 AA batteries. This gives us a total of 12 volts. Firstly, we can remove this controller. Now, as we can see here, it appears that the wiring for the motors only has 2 connections. Logically, they'll be positive and negative, meaning they must be DC motors. This is the actual layout for this circuit. As you can see, it's relatively simple. Basically, everything plugs into either the Arduino or the motor driver, and it's done. Okay, so how does a servo motor actually work? Well, it has 3 pins, negative, positive, and the control. The control pin is the most important here, because it allows us to send signals to the circuit inside it, changing the degrees of rotation to a gearbox, literally a box with gears and axles inside it. And this rotates the servo head we saw in the previous animation. These signals are called pulse width modulation, PWM for short. This project uses an Arduino. I need to write a program for the robot to follow. Right now, this is just a blank program with some default code that the IDE provides. And this is the finished code, which receives the input from the ultrasonic sensor. If the distance it detects exceeds 20 centimeters, the robot will reverse, and the servo with the sensor attached looks left and right. The direction in which the robot will turn is dependent on the distance the sensor picks up when looking left and right. Hopefully this should keep it from crashing into walls and other things.